Welcome back. In this video, we are going to study pyramids. Pyramids are a wonderful shape family because they look very different from prisms, but they also follow clear and elegant patterns. As always, focus on understanding the structure. Once you understand the structure, the formulas make sense. Let's begin with examples of pyramids and non-examples. So, what makes these solids on the left pyramids? The main features are there is one polygonal base. The other faces are all triangles. And these all the triangles meet at a single point. This top point is often called the apex. So a good definition is that a pyramid is a three-dimensional solid with one polygonal base and triangular faces that meet at a single vertex called the apex. Now let's consider three examples: a triangular pyramid, a square pyramid, and a pentagonal pyramid. Again, the name comes from the shape of the base. A triangular pyramid has a triangular base. A square pyramid has a square base. A pentagonal pyramid has a pentagonal base. Now let's determine the number of faces, edges, and vertices for each one. The triangular pyramid also has another name. It's called a tetrahedron. It has one triangular face and three triangular side faces, a total of 4 faces. For its edges, there are 3 around the base and 3 going from the base vertices to the apex, a total of 6 edges. For the vertices, there are 3 on the base and 1 apex for a total of 4 vertices. Our square pyramid has 1 square base and 4 triangular side faces. That's a total of 5 faces. For the edges, there are 4 around the base and 4 from the base vertices to the apex for a total of 8. For the vertices, there are 4 on the base plus the 1 apex for a total of 5 vertices. For our pentagonal pyramid, it has 1 pentagonal base and 5 triangular side faces for a total of 6. For the edges, there are 5 around the base and 5 from the base vertex to the apex for a total of 10 edges. And for our vertices, we have 5 vertices around the base and 1 apex for a total of 6 vertices. Now, let's generalize. Suppose the base is an n-gon. There will be n triangular side faces plus 1 base, a total of n plus 1 faces. For edges, there are n edges around the base and n edges from the base vertices to the apex, a total of 2n edges. And for our vertices, there are n around the base and 1 apex for a total of n plus 1. This is another excellent example of pattern finding in geometry. Let's look at using these formulas. What type of pyramid would have 11 faces, 20 edges, and 11 vertices? Since the faces is the number of sides in the base plus 1, we know we would have 10 sides in the base. This means the base is a decagon. 2 times 10 sides would give us the 20 edges, and the 10 plus the 1 extra vertex would give us 11 vertices. All 3 match, so this is a decagonal pyramid. What type of pyramid would have 40 edges? Well, we know 2 times the number of sides would be 40. That tells me that the number of sides in the base is going to be 20. It'll be a 20-gon pyramid. This will result in 20 plus 1 faces and 20 plus 1 vertices. Next, let's consider a pyramid that has 31 vertices. Well, since the vertices is the number of sides plus 1, the base needs to have 30 sides. This tells me it will also have 31 faces, and 2 times 30 would give us 60 edges. As you compare prisms and pyramids, notice how useful the base shape is. Once you know that the base has n sides, a lot of the structure follows naturally. This is a great opportunity for teachers to ask, how many bases are there? What shape are the side faces? Do all of the side faces meet at one point? These kind of questions help students move beyond memorizing names and toward really understanding shapes. You're doing important mathematical thinking here. Geometry is not just about recognizing a picture. It's about analyzing structure, noticing regularity, and explaining why patterns happen. In the next video, we'll look at a special family of solids called the platonic solids.